Lesson 4.1, Graph quadratic functions in standard form. Many physical events can be modeled with quadratic equations, such as projectile motion. The graph of a projectile, such as a baseball or cannonball, versus time looks exactly like the path the projectile takes. Quadratic function is the form y equals ax squared plus bx plus c, and its shape is a U shape, otherwise known as a parabola. Looks like that. And sometimes it opens up, or sometimes it opens down, like a reflection over the x-axis. It'll open up if the a is greater than 0. And down if the a is less than 0. So if a is positive, it opens up. If a is negative, it opens down. If the absolute value of a is greater than 1, so it's more than 1 or less than -1, then it's narrower. If a absolute value of a is less than 1, so it's like a half or a negative a half, then it'll be wider. The vertex is the highest or lowest point. The x-coordinate of the vertex is found by -b over 2a. The y-coordinate is found by plugging in the x-coordinate into the equation. The axis of symmetry is x equals -b over 2a. You can see it's the dotted line on the picture. And it divides the parabola into two parts, where each side is the same. How to graph in standard form. First thing you have to do is find and plot the vertex. Remember, the vertex was -b over 2a, give you the x value. Make a table around the vertex, then draw a curve through at least 5 points. More than 5 points would be fine, but you must have at least 5. For our first example, let's graph y equals -x squared plus 2x. Start by finding the vertex. So x of the vertex equals -b over 2a. In this particular problem, b is the 2 and a is a -1. C will be 0. So fill in the b and the a, and we find out that the vertex will occur when x is 1. So we make a table of values with a vertex in the middle. So here's my table. I got it off a calculator. Notice I let the middle be x is 1, which is my vertex. That's my vertex there. And then I pick numbers on both sides. Notice the y values are symmetric as I go away from my vertex. Plot the points. And draw a nice parabola through the points. And there you have it. That is your graph. Let's try graphing another. Start by finding the vertex. The x value of the vertex is -b over 2a. In this particular one, a is 2, b is 6, and c is 3. If I plug in the a and the b, I get -6 over 4, which becomes -3 over 2. Make a table of values with that negative 3 over 2 in the center. Notice the center of my table, I have negative 3 over 2. And I pick some numbers on both sides, and I plug them into my equation up here to get the y values. Use my calculator to make the table. Graph the points. Notice I have at least 5 points. Draw a parabola through the points. And there's your graph. Notice in the two examples, the y value of the vertex was the same as the x value of the vertex. That will not always happen. That is just coincidence. To find the y value, you take the x value, you plug it into your equation to get the y value. Find the minimum value. Well, since a is positive, the a is 4, it'll open up. So the minimum value will occur at the vertex. The x value of the vertex is negative b over 2a. In this problem, b is 16, a is 4. So plug in the 16 and the 4, we get negative 2. But that's not our answer. The minimum value of the function is the y value. So we need to take and plug in the negative 2. So find the y value by plugging in the x value. So we fill in a negative 2 for the x, simplify, and we get negative 19. So the minimum value of the quadratic is negative 19. Let's do a word problem. A video store sells about 150 DVDs a week for $20 each. The owner estimates that for each $1 decrease in price, about 25 more DVDs will be sold each week. How can the owner maximize the daily revenue? Well, in general, revenue is how much money comes in. So for this problem, revenue will be the price times the number sold. Our price will be the $20 that they sell each DVD for, minus the $1 decrease every week. So it'll be $20 minus $1 times the number of decreases. The number sold is 150 that he's selling each week, plus the 25 extra that he sells each week. So the number sold will be 150 plus 25 times the number of price decreases. That as a function. Our revenue equals 20 minus x times 150 plus 25x, where x is the number of times we decrease the price. Let's multiply those together. So we're doing a little bit of FOIL. So we have the 20 times the 150, it gets the 3,000. 20 times 25x, to get the 500x. Negative x times 150 to get the negative 150x, and negative x times 25x to get the negative 25x. Combine like terms and rearrange it to be in standard form. You get this for the revenue function. We want to maximize our revenue. Notice the a is negative 25 here, which means it's going to open down. So it'll look like this. So our maximum will be here at the vertex. To find the vertex, it's negative b over 2a. In this problem, b is 350 and a is negative 25. Fill those in, we get 7. So x is 7. So how can we maximize the revenue? Well, let's take the 7 and fill it in for the x to find our y. and we get $4,225. So the owner should drop the price 7 times, because X was the number of times we dropped the price, and making a revenue of $4,225. Here is your assignment for the day. Have fun.